Hi, it's fantastic to be here at the EDA Summit. My name is Mark Fussell. I'm a co-founder and CEO of Dapr, and it's amazing to be here today to talk to you about building portable, event-driven applications with Dapr, which is an open source framework. Alice.
Hi, everyone. My name is Alice Gibbons. I'm a customer success engineer at Dapr, and I'm really excited to share with you some insights on Dapr PubSub.
So let's dive into some slides here. So let's kind of frame the conversation a little bit about developer challenges today. So today, developers have to be building these distributed, scalable applications. And they have to kind of often take on building something like this fictitious e-commerce application, which consists of a number of different services, often with a sort of a microservices architecture. And of course, inside here, you've got event-driven architectures with messaging. You've got request and response architectures with direct invoke. You've got statefulness. You've got a whole variety of different types of patterns that the developers to build the overall solution. But building these things is not straightforward. It looks easy on the surface, but when you get down to it all, is how do you discover applications? How do you call them securely? How do you send messages to multiple applications that are listening on a topic? How do you do retries? How do you do queries that are secure to your database layer? And many of these difficulty nuances start to come into play. So looking at this problem space, we started this open source project 4 years ago called the Distributed Application Runtime, or short name called Dapr. And Dapr's goal was to codify the best practices for developers building these distributed applications so that they could be productive, building them in half the time they would expect. And so what the Dapr does is it provides a set of APIs that you as a developer can use to build distributed applications with a microservices architecture rapidly. So what do these APIs look like? They have a range of varieties that solve these distributed patterns. So for example, a common pattern that we're going to talk a lot about in this talk is publish and subscribe for event-driven architectures. And so inside Dapr itself has an API for this. If you want to create long-running stateful applications, it does state management. If you want to do direct calls with request response pattern, it has service invocation, which not only does discoverability, but it does retries and it does security between them all. If you want to manage secrets, because you want to talk to a resource like a database, or even if you want to build like a workflow application. So these APIs are exposed through HTTP or gRPC and are available from any development framework. And that's the beauty of Dapr. You can pick just one of these APIs, you can pick many of them. And using these APIs, any developer can come from any framework to build distributed applications in half the time. Now, Dapr itself can run on any distributed systems platform, although primarily nowadays we see that running on top of Kubernetes, hosted in sort of any cloud. But it's agnostic to that. And as I mentioned, these APIs are very composable about how you pick them up. Diving a little bit more deeper about what this means to you as a developer, each application you run or instance of a microservice you run has Dapr running as a sidecar. And so from a developer perspective, a developer has to think about these just consistent portable APIs. So for an example, if I was wanting to call the order method with a request response pattern, I can use invoke API. Or as we'll dive into a lot today here, we'll be using the publishing API for publishing messages and receiving topics using the publish API. And as of course, you can see here, there's workflows, there's secrets, all of these composed together into a single sidecar that runs as part of your application, and you run many instances of this. Now, behind each one of these APIs is another key to Dapr, and it has this concept of components. And what components allow you to do is they allow you to plug in underlying infrastructure behind those APIs. So for example, for state stores, I can plug in a variety of different state stores, whether it's AWS DynamoDB or Google Firebase or an open source database like Redis. And so now that API remains consistent, gives me portability of my code, but I can change my underlying infrastructure. And this allows me to develop applications locally, move them to a cloud, do multi-cloud type applications, and effectively also even gives me the flexibility on my design choices that I may change later. As you can see here, one of those pluggable components are PubSub brokers that we'll spend a lot of time diving in today. And the amazing thing about this is that the community has developed many of these brokers to put as part of the Dapr open source project. And there's over 18 of them, and they grow each time we do a release, which is 4 times a year. So these components help with the portability of your code. So let's take an example. If I was to build an application like this application here that receives reading some secrets from a HashiCorp vault, sending messages over a RabbitMQ as a broker and receiving those and storing them inside a Redis database. I can switch them out with no code changes to, for example, choose AWS component infrastructure using a key management service, using SNS as the intermediary broker and a DynamoDB as a state store. Or I could switch them out again and use Azure components to do the same. So the consistency and the portability here means that Dapr's APIs are sort of becoming standardized across the industry, because so many developers today are required to fit into multi-cloud or not have to understand all the complexities of having to learn particular specific APIs. So this also saves development time, so you're not struggling to pull in APIs that you have to learn for a particular technology and get to grips with it all. That's been done for you as part of the Dapr open source project. The project itself was released publicly in October of 2019, and since then it's grown enormously. So it has 21,000 GitHub stars as a kind of a measure of its popularity, but the core of this is the contributors. 2,500 contributors who contribute their time and their energy to the project. Dapr itself is part of the Cloud Native Computing Foundation, CNCF. There is the 10th largest project as part of it. You see a healthy Discord community, and you see that a wide range of organizations contribute to this, donating their time, their energy, and their engineers. So a very popular, large, growing project that has a big user base. And when you look at across the breadth of the different companies who are using it today, all in production, they range from sort of hyperscale clouds like Alibaba and Microsoft to their enterprises like Zeiss, Bosch, and Intel, to kind of the cloud savvy Zscalers and the Fujitsus of the world. And one important fact that we simply love is that Dapr itself is actually used by NASA on the International Space Station and deployed on a Kubernetes cluster that's running there. So with that, I'm going to hand it over to Alice, and she's going to dive a lot more into what the pub/sub capabilities of Dapr are.
Awesome. Thanks, Mark. So as Mark mentioned, there are over 10 building block APIs that Dapr has, and these are all available to you on an opt-in basis. So you can take advantage of one or as many as you want. Today, we're primarily going to be focusing on publish and subscribe, which enables you to have secure, scalable messaging between your services. So let's go into some features of the Dapr pub/sub API. So it is a platform agnostic API that has integration with over 18 message brokers and queues. These are entirely configurable with a YAML file, so you can swap these out whenever you want to, and this removes the broker dependency on your service, making your service more portable and agile. It also guarantees at least once semantics, so at least once message delivery to every subscriber, and you can subscribe either declaratively or programmatically. So you can either use a manifest file with YAML, or you can use your code depending on whatever suits your need. Dapr uses the cloud event specification to send its messages. This is conforming to another open source standard that's quite popular in the publish and subscribe space. And it has the auto creation of consumer groups. So automatically supports the competing consumers pattern across all of its different brokers, even if the underlying broker does not actually support that. From a message routing perspective, you can use content-based routing to deliver messages to any of your proper recipients. And it allows developers to set dead letter topics as well as resiliency policies to avoid endless retries and building up of unread messages. Last but not least, with Dapr pub/sub, you can add a bunch of layers of security on top of this. You can essentially limit which applications can publish, as well as which applications can subscribe to your apps using what's called topic scoping, which I'll get into. So how does this all work? Essentially, your service, in this case, I have my React front end, which is my publisher, and then I have a Python subscriber, which is the app subscribing to my app, to my React front end. My front end makes a call to my Dapr sidecar. You can see here that this is over localhost because Dapr is running as a sidecar, and I'm publishing essentially using the Dapr pub/sub API, which will makes a call onto the Dapr pub/sub component on behalf of your service. So in this case, I'm using Redis, but I could use anything I really wanted to here. And I'm publishing on a pub/sub broker that is named pub/sub, and I'm publishing onto topic A. So this is all seen using my post request right here. And then on the subscribing side, Dapr will actually subscribe on behalf of your application and then route the message, including its data, to whatever route that you specify within the subscription. So in this case, I'm routing on my Python subscriber to route A, and you'll see that that data comes through there. As mentioned, Dapr does use cloud events, and it automatically wraps every event within the cloud event spec, but you can also disable this for integration with legacy systems. From a response perspective, Dapr assumes any non-error response this implies success, but you also have the option to provide explicit statuses like retry or drop from your subscriber code. As mentioned, there are these number of different Dapr components that you can use. So, if I wanted to use Redis one day, but then I decided to swap something else out later, that is something that is totally doable with Dapr without any code changes. These are all open source components that are written in Go, and you can see there's a huge number of these. There's actually around 18. And we have support for Solus through its AMQP PubSub as well as MQTT broker. So this provides an abstraction onto your code and means that you do not have to, do things like import the Redis SDK into your publisher or subscriber, but instead you can call these Dapr APIs directly. You can see here that I have a specific Redis component spec, and this is named PubSub in this case, and it is giving the details for wherever my Redis host connection is living. So I have metadata for both the host and the password, and this is what makes up a Dapr component YAML file. From a subscription perspective, as I mentioned, there's two different ways to subscribe using Dapr. You can go entirely declarative and remove every dependency from your code using these subscription specs. And this is defined in an external YAML file like the one shown here. Again, this removes the Dapr dependency from your code, and it allows for existing applications to subscribe to your apps without any code changes. So on the right here, you can see an example of a subscription file. This is named Route A. And essentially what I'm doing is I'm subscribing this application to topic A, and it's routing all of the messages from topic A to Route A on my app. And in this case, from the PubSub named PubSub. And I am using the scopes here to define that only the Python subscriber should receive these messages. And this really shows the idea of Dapr's application identity. And application identity is an idea that really is at the core of Dapr. And in this case, I have an app named Python subscriber with its app ID, which is allowing me only to send messages to the specific app. The other way that you can subscribe is through programmatic subscriptions. So this would be like a very typical way in the application code. And essentially what happens is on startup, the Dapr runtime calls out to the /Dapr/subscribe endpoint and gets back a list of subscriptions that the app subscribes to. So in this case, you can see in this code sample, I have a Dapr subscribe endpoint, and I'm returning it, again, the PubSub name I want to subscribe to, along with the topic and the route that I want to send the messages to. And then you'll notice on the bottom here, I also have a route for A, which is where I want to route the messages for this topic, and that will be where my business logic lies. So let's see how this works in practice. So if I jump over to my Visual Studio Code terminal, you'll see that I have both my React publisher and my Python subscriber. So this first code is my React publisher, and you can see I have a number of environment variables here. I'm setting some very specific to Dapr. For instance, you'll notice I'm calling again over localhost because Dapr runs as that sidecar pattern. I'm also setting that PubSub name to be PubSub, which is what I'm going to be using throughout this presentation. For my post request, I am posting on the publish endpoint, and I'm posting to this PubSub named, which is PubSub, and then I'm posting to whatever topic that I pass into the header. So this is my publisher. My subscriber is also very basic. It is a programmatic subscriber, and it is doing essentially the same thing as I was showing on the code before. So I have a route for /Dapr/subscribe, and this is going to be returning all of the topics that I want to subscribe to on this particular broker. So for instance, I would like to subscribe to topics A and C, and I want to route them to their respective routes. In this case, both A and C routes, which I have defined endpoints for in the code here. And this is all connected together using a component file, right? And so I have this component manifest file here. Again, this is named pub/sub, keeping that throughout each of the code samples. And then I have my connection details as well in the metadata. And this is really important because these connection details, like this could be anywhere, right? Like I have decided that I want my Redis server to be living, in this case, on Kubernetes. I've deployed it on a Kubernetes cluster, but it could be in a managed service or it could be running locally on your machine. Okay, so I have this deployed on Kubernetes. So you'll see that I have 2 pods running. I have both my React front end and then my Python subscriber. And then I also have my pub/sub component, the Redis one I just showed here. So to make a publish a message, I'm just going to flip over to the browser and then I'm going to send a message here. So this is just message 1. And how this works is it's going to send a message on topic A on whatever message type I choose, and it's going to send it to my subscriber, hopefully. So I'm going to click send, and then I'm going to jump over to my terminal, and you'll see on the top here, this is my publisher. This is my React form I was just showing in the browser. And on the bottom, I have my Python subscriber. So this was actually able to send message 1, and I can see that it was actually sent and it was received on topic A within my Python subscriber, which is great. Let's see if I can do that with switching a component out. So not only do I have a Redis component, I also have a Kafka component as well that I can use. So you can see here, I have this other component file looks very similar to the Redis component. I have, it is of type pub/sub Kafka. It is named the same thing. This is a very key idea within Dapr. And it has some different metadata properties. So essentially each of these components can be different from the metadata that it supports, and including, of course, where that broker actually lives. So let's apply this. Make sure we apply the right one. And then I'm just going to delete my replica sets to ensure that the Dapr sidecars get the new version. And then I'm going to just restart these logs here. Okay, let's try again. So essentially, I just swapped out the component and I haven't changed any of the code, right? I still have my React form running. It's just a new version of the container. And I still have, or it's a new replica, I mean, and I still have my subscriber running. So I'm going to send another message on A. This is message 2. Let's send this guy. Let's see what that looks like in the logs. So you'll see, again, I've got this message A and this was message 2. And then on my Python subscriber, I've also seen this being sent. Similarly, if I want to send a message on topic C, so this will be message 3, this should be on topic C. And I'm going to send this one, and then I'm going to flip over to my logs, and you can also see that this is message 3 on topic C, and I also got this one because my Python subscriber is subscribed to both A and C topics. So it looks good. That was using both Redis and Kafka components, again, running in my cluster. Switching back over to slides for a second, I just want to jump into some more detailed features of what Dapr gives you. So we just put our demo. Some of the more detailed features from the Dapr Publish and Subscribe API. Dapr has the concept of application identities, as I was mentioning before. So for PubSub, each app identity gets it gets its own consumer group, meaning that Dapr will handle the idea of competing consumers for you. So for instance, you can see on this example, if I have a publisher and it is named application 1 or app 1, and I have subscribers that have multiple replicas running for app 2, I'm only ever going to receive this message on one of these replicas. Similarly, if I have a publisher that is publishing to multiple different applications, again, each with their own app identities, then Dapr will send, with at least once delivery, a message to each one of these apps because they have their own app ID. And again, this is applied across all PubSub brokers, regardless of the implementation. From a resiliency standpoint, Dapr has resiliency that can be applied across all of its APIs, so all of the building blocks that we were talking about earlier. For the Dapr PubSub API in particular, though, there are 2 places where you might want to apply resiliency, and this is outbound from your publisher, as well as coming inbound after the message goes through the broker into your subscribers. Additionally, many PubSub components also have, retry capabilities built into the infrastructure, and Dapr actually acts on top of these, ensuring that you get, that additional layer of resiliency within your applications. So for example, if I want to apply a resiliency policy to my subscribing app to ensure that, all the messages that come from my PubSub broker get delivered to my Python subscribers successfully, I might configure a policy that looks like this. And this is, again, a YAML file that I would use and Dapr would load at runtime. And this is going to essentially try to deliver the message 10 times every 5 seconds. And it's going to try constantly to ensure that, my Python subscriber receives this app. Dapr also has support for dead letter topics that can be used along with resiliency to ensure that your applications are having, constant communication for, all your distributed systems. Last but not least, I just wanted to talk quickly about some of the security features that the Dapr APIs have. So there are many different security features that can be layered on top of the APIs. One of them is just limiting the access of the publish and subscribe API with scopes. So both namespaces and component scopes can be used to limit component infrastructure access from the applications. So for the PubSub Dapr API, you can essentially provide both publishing and subscribing scopes, as well as allowed topics as configuration policies. So for instance, essentially this is like which topics can be used on the broker, which applications can publish, and which applications can subscribe. So you'll see here in my publishing scopes, I'm saying if I really want to lock this app down, I'm saying my React form can only publish on topics A and C, and my Java and Python subscribers cannot publish at all. From a subscribing standpoint, only my Python subscriber can subscribe to topic A, and my Java subscriber can subscribe to topic C. And then in general, I'm only allowing a certain amount of topics on this broker, which are A and C in this case. So let's see how that looks like in practice. So I'm going to jump over to my terminal again and just show you a more advanced example. So just like I had this Kafka component, I also have another component for scoping. And you'll see that this is another Redis component. But essentially, if this is my old Redis component on the left-hand side here, and my new one is exactly the same, except I've added some additional metadata properties to the bottom. And this is exactly what I was just walking through. So for instance, I'm only allowing topics A and C. I'm only allowing my React application to publish, and I'm only really allowing my Python subscriber to subscribe to topic A, even though in the code, I'm actually subscribing to both topics A and C. So let's apply this. Should apply the right one. And we got to cycle those pods again one more time. And then I'm just going to set up the logs really quick. Go. And then this. So, okay, I have my new component that's actually applied on my cluster now, right? So technically, if I do, this is my, new message here. This one, I'm going to push on topic A, okay? And I'm going to see what happens. So if I jump over now to my terminal, you'll see that this was message A, and this is sent on topic A, and the new message, and this was actually allowed. Because if you remember from my actual code, I'm saying, Python can actually subscribe on topic A. But that's just based on this specific line of code here. But if I try to send a message on topic C, it should not be allowed, right? Even though it is actually running in my code, I should not be allowing that because Dapr will apply these security policies on top of your code. So this is going to be message 2. I'm going to click submit. And then if I come back to my terminal, you'll see that I said this message 2. This is showing up on my publisher, but in fact, it's actually not showing up on my subscriber. So Dapr successfully applied this policy to ensure that, my Python subscriber did not receive that app. So jumping over to the logs for this, you can see if I look at the Python subscriber Dapr D logs, And these are the Dapr sidecar logs, essentially. I'm going to see a bunch of stuff in here, and this is where you want to go to do like your debugging or want to go to get a better idea of what's happening within Dapr. But essentially, I have that this app is subscribed to the following topics. That was what was happening in code. But then you'll see this line down here that says, well, beginning pub sub on topic C, the subscription topic C is not allowed, right? Because we added that into its component. So that's great. The last thing I just wanted to show really quick was if I tried and send a message on topic B. So if you remember, only topics A and C were allowed on this broker. So I'm going to say like test B, and I'm going to send this one through. And then I'm going to jump over now again to my code, and you'll see I got a error, and it says topic B is not allowed for app ID React form. So not only is it not allowed for React form, but it's not allowed for this pub sub broker at all. And of course, it did not actually get sent through correctly to my Python subscriber. So just wanted to show an extra layer of security that you can apply onto your Dapr applications through pub sub.
Well, thanks, Alice. I'll pick it up here. That was an incredible overview of the power and flexibility of the Dapr's APIs. And also shows the kind of ability to kind of create that portable set of code. The way we look at it is there's this incredible synergy between Dapr and Solace that you can achieve as a developer. You can look at it from all of Dapr's pubs API, but also its other APIs for helping you build those distributed applications. And when you look at the components that are available across the range of APIs, coupled with all of the Solace connectors as well, you can achieve a huge amount of distributed application building as well as connectivity to other applications. Of course, taking advantage of Solace can be done through the MQTT pub sub component, as well as Solace's AMQP pub sub component, both of which are available in the 1.10, which is the current release of Dapr, and can continue to be supported in future releases. And I'd also encourage you to listen to the other talk at this conference, where we show how Dapr can be used with Solace Event Mesh. In that realm, you now take Dapr beyond a single deployment, so it can do cross-cluster, cross-region, cross-cloud communication between these Dapr applications, turning it into a very powerful, flexible, portable, distributed application across multi-cloud, using, of course, Solace Event Mesh. And then finally, another place where both these Dapr and Solace align deeply is around the observability and monitoring. Both of them are based around open telemetry. You can pull an open telemetry from your application calls, your pub sub messages can all be seen inside there. You can trace them all through end-to-end with open telemetry events. And of course, you can also combine that with the open telemetry that comes from Solace itself to see a true viewpoint of what's happening inside your application. So it'd be great if you would like to reach out to us. We're more than happy for you to come and send us email. We both work for a company called Diagrid. Diagrid focuses on boosting developer productivity by providing tools and API for building cloud-native applications. And we're very focused on contributing to open source for Dapr projects, as well as helping developers be successful. So please reach out to us at these email addresses below. We'd love to hear from you, and we'd love to hear particularly about the stories that you have if you have a building Dapr into your projects. And then finally, I'd just like to wrap this up. If you want to find out more, go to dapr.io and look at some of the quick starts there. The code that Alice showed today is available at this GitHub link here, which is one of the tutorials we have inside there. And of course, to ask more questions, find out more about Dapr, you can go to our Discord alias, you can follow us on Twitter. And as I mentioned, please reach out at us at diagrid.io if you want to find out more about building distributed applications with Dapr. We'd love to hear from you. And with that, I want to say thank you very much.
Thank you.